Unit 6, Proportional Reasoning and Solving Proportions. In order to solve proportions, we need to remember what exactly ratios are. And they're a comparison of two or more numbers using the same units, and they can be represented in colon form, where you have a colon between the two numbers, verbal form, using the word to, or fraction form, where we've written it as a fraction. The key here is we have to remember the 4 is first, and in the numerator. The location of the ratio numbers is significant when we are solving word problems in order to get the correct answer. Before we do that, though, we need to be able to solve a proportion. And a proportion is an equation of ratios that are equivalent. That is, they're multiples of one another. If I look at example 1, I have two fractions that are equal to each other. And if I look, I've got to solve for x. And I want to see, how does a 7 turn into a 21? Well, that happens by multiplying by 3. So I'm going to do the same thing up top and multiply 1 by 3, and I end up with x equals 3. Now this question here, I have to look at it a little bit differently. 4 times 2 is 8, but I don't know the value of t, and I don't want to multiply by 2, so I'm going to go backwards. Now, how does an 8 turn into a 4? That happens by dividing by 2. So how does the 6 turn into a t? I divide by 2 also, and t has a value of 3. If I look at this proportion, it's a little bit different because it actually has 1, 2, 3 terms to the left of the equal sign and 1, 2, 3 terms to the right of the equal sign. In order to solve, I need to have exactly the same number of terms on either side of the equal sign. If I look at this, the complete pair is the 4 and the 12. How does a 4 turn into a 12? It occurs by multiplying by 3. So now we need to look at the other two variables. I have to multiply the 3 by 3 in order to get 9 for x, and I have to multiply 5 by 3, which gives me 15 for y. Now, example 2 is a little bit different when I solve for the unknowns here. I'm looking for the unknowns, which is x here. And if I look, how does a 9 turn into a 7? Well, that's not going to work nicely. So what am I going to do? I need to write this in a different format and solve it. One of the best ways to do this is write it in fraction form. So I can write x over 5, because they're both in the first spot, equals 7 over 9, because the 7 and 9 are both in the second spot. And you'll notice that the numbers in the numerator both come from the ratio to the left of the equal sign, and the numbers in the denominator both come from the ratio to the right of the equal sign. How can we solve this? This is just like solving an equation. I want to get x by itself, so I can multiply both sides by 5. So I've got 5 times x over 5 is 5 times 7 over 9. And you'll notice the 5's reduce, and I'm left with an x on the left. And remember, any whole number can be written as a fraction with a denominator of 1. So we multiply the numerators across, and we get 5 times 7 is 35 over 9. And before class tomorrow, please do page 5, Solving Proportions, number 1, 2, and